ladies and gentlemen, in this video we are going to discuss our question 132 pattern. So in the input we are given an array filled with numbers. We are required to check if our numbers and its subsequence can form a 132 pattern. We are going to discuss what a 132 pattern is. If yes, they can form a 132 pattern, we have to return true. That is not the case, we are simply going to return false. So let's first understand our question. So 1, 3, 2 pattern. Right. So we are given an input array. So let's take 132, just 132, so that we understand what 132 pattern is about, what it indicates. Okay. So 132 pattern, let's say we got numbers 132 only. Okay. So now this is your 0th index, this is your first index, and this is your second index. So here we are given that we have to take such that the three numbers, such that I is the first one, j is the second one, and k is the last one. So what we mean here, that here in our case, I is the 0th index one, then after I, j will come, and after j, k will come. So that's the ordering we are given. Now, what a 132 pattern is. So here, as you can see, 1 is the smallest, right? Can I write 1 is the smallest? What else? The 3, the j, that is our j. It is the middle, the j1, right? It is the largest, right? We can notice it. What about 2? 2 is the middle element, that is the middle of smallest and the largest. So middle element. Beautiful. Now that's what we are required to check. If this pattern, that ith will be the smallest, j will be the largest, and k will be the middle element. Okay. Also we can write it as, let's say we are given nums array. So nums I will be the smallest, right? Which is the smallest, nums k, right, will be at middle. And what will be the greatest? Nums j. Right. Also, you don't have to figure it out. We have provided it in our input. I just want to show you that. Right. Nums I, nums k, nums j. Perfect. Now here, for 132 pattern, of course, it is following that this is smallest, this is largest, this is middle. So if that's the case, if it follows the pattern, we simply have to return what? Return true. Right. Now let's see some more cases so that you understand our question completely. Let's say we are given 4, 8, 3. So do 4, 8, 3 follow our 132 pattern? Let's see that. So 4 is the smallest. Yes, 4 is the small. 4 is not the smallest. 3 is the smallest. So here a condition is not true. So we are going to simply return false. Right. So we have seen both a true case and a false case. Now let's see more cases. Right. So here I'm going to create some space. So this time let it be 3, 9, and 3, 9, and 5. So here, as you can see, 3 is the smallest, right? J, that is I denotes 3. It is the smallest. Then J is 9. It is supposed to be the largest. Yes, it is the largest, right? And M and 5 is in the middle, right? Our K is supposed to be middle of both the elements. Yes, it is in the middle. So for this, our condition is true. Now, you must be wondering that are we given only 3 size array? No, it is not, as it is mentioned that we are required to check for all the subsequence. So let's see a example of more size than 1, more size than 3, not just 3. Okay, so let's see example. So let it be what? 2, 4, 8, 3, 1. Right. And let me add more digits here. Yeah. Okay. So here is our example. Okay. So we are required to check if they follow 132 pattern for all the subsequence. So first let's talk about its potential, its possible subsequence. Its possible subsequence can be many, there are many. Let's see few of them. It can be 248, right? It can also be 243. It can also be 243. It can also be 318, right? It can also be 184, right? There are plenty numbers of subsequence, right? So if any of the subsequence, let me write it here. If any, we know any of if any of our subsequence follow 132 pattern, so that means we have to simply return true, right? So here in our case, let's see if anyone follow 132 pattern or not. So I can clearly see a case starting with 283, right? So 283, or you can say 243, right? 243 simply. So as we can see here, it is our smallest, right? It is the largest here. It is in the mid. So we have to return true. There can be many subsequents following our pattern, right? But we simply have to check for one. If we got one, we have to simply return true, right? So that's it. If you still don't understand, I want to show you one more example. Okay, so let it be -1, 2, right? -1, 2, 3, 0. Or wait. Yeah, -1, 2. Yeah, the same. Let's take the same. Okay. So here, let's understand it to the diagram. Okay, perfect. So what we are given is -1, 2, 3, 0. Okay, this is, let's suppose, -1, then 0, then 2, then 3. This represents the height, right? So first, your -1 will be here, right? Then 2 will be here. Then 3 will be here. Now 0. As you can see, 0 is coming in the middle. In the middle of what? In the middle of -1, 2, as well as -1, 3. Right? That means that you got a potential answer. Right? So you have to print true. That they are following 132 pattern. As you can see, -1, 3, 0, as well as -1, 2, 0. They both are following. So you have to simply print true, return true. Now that you have understood, let's discuss few approaches. Okay. So before, yeah. So let's discuss few approaches. First, brute force. Right. Let's brute force it. Let's discuss it. The first approach. Right. What it can be. Like how we can get to know that if our number follows 132 pattern or not. So here, I will copy this. Right. So that you don't forget that what is exactly 132 pattern. Okay. So here I is supposed to be first, then J, then K. Okay. Now that we know this, what we can do is let's take few example. Let's take example. Let's say we are given 3, 4, 5, 6, 2, 9, 8, 11, and plenty numbers. Okay. Now what we can do is, let's say we place our I here. Okay. We place our J here. We place our K here. Now, what we do? We get all the subsequence, and we simply traverse the whole array by all the potential subsequence and check if nums I is less than nums j, right? Whatever the condition was, right? This condition. Okay, let me write this k here, right? If this condition is true, then we are gonna simply return true. Okay, so how this will work? First, your k will traverse, then your j will increase, right? Then your k will again traverse, right? Then your j will increase, then eventually your I will increase. You got the idea that how it is working. So we can say that we required 3 loops for it, right? 3 loops. First, that will run from 0 till n, right? Let's say this is your I. Then it's the second loop. Your second loop will run from I plus 1, right? Run from, let's say this is your j. J will run from I plus 1 till n. And the third loop, that is k. K will run from j plus 1 till n, right? So by this, if you check the condition, and if the condition is true, that means it is you are getting the 132 pattern, and you can simply return true. So of course you got the idea that what I'm trying to convey here, but the point is this approach is not at all optimal, right? It's a very naive approach, and this is gonna take in O cube time complexity, as we are running 3 loops, right? And they are dependent on each other, right? So this is not at all an optimal approach. So let's see one more approach. Let's see more approach, right? This was O and cube approach. Let's see one more approach. So here, let's say we got elements A, B, C, D, E, F, G, H, I, J. Okay, so these are our elements. Perfect. Now what? Now let's say our J. Our J is currently here. Let's take D. Right. So here currently your J is standing. Now, what if have faith in me? I'm saying that we will get minimum till now in ON time. Right. So let's write some elements here. Let's say we got 1, 3, 2. Our D is 5. Alright. And here also few elements 8, 4, 9, and n elements. Right. So here, right, this is my I, right? This side is my I. This is my J, suppose, and this is my K. This is my K. So for I, if I know the minimum here, right? Minimum till now. Minimum till now, right? That is what? As here, the minimum is 1, right? So can I say that the 1 will be the best possible I that I can get, right? Because it's the biggest range, as we know. As we know what? Let me bring it here as well. That nums I is supposed to be the smallest, right? I is always supposed to be the smallest. So if I take the minimum element here, the smallest element, so that will definitely help us, right? So that's what I'm trying to convey. How will that help us? Let's see how will that help us. Okay, so for example, we are starting at J. We know our I is 1, J is 5. Now this time we only need to calculate K, right? Whatever that is K, so this time we can do it in 2 loops instead of 3 loops. We need not to take care for I, because we know that I will be the minimum. If J is here, I will be the minimum element here. So this time only 2 loops will be required, so you can get this in ON square time. Perfect. Now what will we do is furthermore optimize it. Okay, so here again, let me write some elements. Okay, so let's say it is 3, 2, 1, 5, 8, right? And some more elements 4, 6, 7, 8. Again, we are going to do the same thing this time that we earlier did, but there is a twist to this. So what we were just doing is, for example, we are starting at 8, right? Our j is 8. So for I, we were getting minimum on this, and we were getting that in oven time, right? We're getting that in oven time also. If you still don't know that how we are getting it oven time, I suggest you to watch our stock span video. We discussed in that question that how will we get our minimum in oven time. Okay, so here the minimum will be our I. So here the minimum is 1. So 1 will be our I. Alright. Or I will write it here that I will be equal to 1. J, as we can see, is 8. So what do I need here? What will be my K? K will be any element that is greater than my minimum. Right? That was the first condition. That again numbers I K. So K is supposed to be greater than I. We know. Here it is mentioned first. K is supposed to be greater than I. So can we say we need just larger than minimum? Just larger than our I. So for that, till now we have discussed the same approach. But there is a twist this time. We are going to use a data structure that is tree set. Right? So we are going to use this data structure. So what this data structure does is it stores element. Right? It stores element, and for example we need just larger element, right? We need just larger from 5, right? For our minimum, let's say our minimum is 1. So this time in of log n operation, in log n operation, right? Log n operation, it's going to find us the just larger element. So by that we can definitely get our ijk and then check the conditions, right? So the time complexity of our solution is we are traversing j, and for getting k we are using log n time. So the total time complexity will be n log n. Right. Now that we have discussed several approach, now it's time to get to the main and the most optimized approach. So let's see what we are going to do. So again, let's take a array, right? 4, 6, 8, 8, or 3, 9, 2, 1, and 3. Yeah. Or wait, let it be 4 this time. Yeah. So now for this array, we'll be calculating whether it's a 132 pattern or not. So here, first step, I'm going to do nothing and bring this here so that you know the condition. What if this condition satisfy? It is a 132 pattern, right? So K. So first, I will be creating a minimum array. That is minimum till now, right? If you are in the 0th index, minimum till now is 4 only. If you are at 6, minimum till now is 4 only. If you are 8, minimum till now is 4 only. If you are 3, so 3 is lesser than 4. So this time minimum will be 3, right? Now again 3. 2 is lesser than 3. So this time it will be 2, then 1, then 1. Okay. So what we'll be doing this time is we know the minimum, and minimum act as our I, as we discussed in the earlier approaches. Right? The minimum will act as our I. So in the first step, we right. So here to calculate our J and K, we ran two loops, right? So here we did an O log n operation. Now we will try to do in O n time, right? So what will we do is use the help of stack, right, and its property. So let's see how stack can help us. I'm going to create a stack. So here is our stack. Now what? Now first I want to tell you something, that the minimum element, that is I, right? Minimum is going to act as what? wait, sorry, as I for us, right? And we are traversing for j value. And what is k value? You will understand. Okay. Okay, perfect. So first, for 4, we know that 4 for 4, like it's the first value, there is no k. We are gonna do nothing. We're simply gonna push it. Right. Now we pushed it. We got at 1. Right. Let me delete this. Okay. Okay, now what we will do? Let's see. So I'm gonna break it into steps. So first, what was the condition? That nums I, right? Nums I should be less than nums k. Right? Here our I is 1. Right? Here our I is 1, and what is our k? Our k is the top element of our stack. So that's what I want to tell you. So what will I do? If we know that nums I can never be greater. So if nums I, right, and nums I is our minimum, right? So if nums I, or I can write minimum here, right? If it is greater or equal to what? Top stack element. If that's the case, then I'm gonna simply pop. I'm gonna pop, right? So let's do it first and then we will write further steps. Okay, and our last step, we know that is to do simply push. Okay, so here our I is 4. Our I is 1. Our I is equal to 1 and our k is equal to 4, right? And we can see that I is not greater than 4, so we need not to pop anyone. Then what we are gonna check? Let's see. So we checked for I and k. Now our task is to check for j. So what we are going to check, that if j value is greater than top element of our stack, top stack element. That means what we checked now is that I is greater than k. Right? Now we have to check, we have to relate k and j. Right? So this time, what is our j? Our j is equal to 1. So here, as we can see, I is less than k, but j is not greater than 4. Right? So the condition is not true. The condition is not true. We are gonna do nothing. We are gonna get to the next element and then we are gonna push 1. Okay, we pushed 1. Our k will become uh, our k will become 1. Now, now our I is equal to, let me write it here, I is equal to 2. I checked that my I is less than k. Is I is less than k? No, I is not less than k. Right? So what I have to perform is pop. Right? My minimum is greater than top element of my stack. Okay? Now, again, if that's the case, I want to check if 2, that is my minimum, is it less than top element of my stack? No, this time it is not less than top element of my stack. That is 4. Right? And what is my j this time? My j is also 2. So j value is not greater than 4. 2 value is not greater than 4. So the condition is not true. So if not true, what I have to do is simply move, right? And here also move and then push. What push? 9. Okay, let me erase it. Right. Now, again, we are at our j is equal to uh we had to push our i's here. Wait, I got to undo. Wait. Where were we at? Yeah, our j and I were at 2, right? So we have to push 2. I pushed, sorry, yeah, I pushed 9 here. Let me raise it. We push 2, right? We are gonna push 2. So our k is 2. So this time our j is equal to 9, our k is equal to 2, and our minimum, our I is equal to 3. My first condition is 3 is less than 2. No, 3 is not less than 2. Then I'm gonna simply pop this. Now the next condition. What was my next condition? Again, check for the top element of my stack is 3 is less than 4. Right? 3, my I is 3. So as you can see, 3 is less than 4. Then if that is true, of course. Then I'm gonna check if j's value, if 9 is greater than 4, right? So j is also greater than 4. So that means that matches our condition. So as you can see, 3, 9, 2 matches 1, 3, 2 pattern. Right? Wait, actually 3, 9, 2. We did something wrong here. So yeah, as we can see, 3, 9 are here, k is 4, right? K is 4, right? So 3 is greater, 4 is greater than 3, and 9 is greater than 4. So that means 3, 9, 4 follows our pattern, that is 1, 3, 2 pattern, right? So that's our approach, and that's how we'll getting our answer. Now let's try to code it. It was not that difficult, right? So our first step is to get the minimum array. So vector integer type min array of n length, right? So we know that we are getting minimum till now, right? So minimum 0 index will be equal to nums 0. Now we are going to run a loop, right? For int I is equal to 1, I is less than n, right? And get its minimum till now. So min array I is equal to standard function minimum we are going to use minimum of minimum till now, minimum array minus 1 comparing to your value, that is nums I. Okay, so that task is minimum array task is over. Now of course we will be requiring a stack of integer type st. So we created a stack. Now what? Now we are gonna run a for loop, and we know that we are gonna traverse it from the back. So int j is equal to also here int n is equal to nums dot size, so that we don't have to write it again and again. So j will run from n minus 1, j is greater than equal to 0, right? And j minus minus. Now I know that if my minimum is greater than the top element of my stack, right? Minimum indicates I, and I can never be greater, so I will be requiring minimum. And minimum equal to min arr j, right? I got minimum. Now I will check while my stack size is greater than 0, if that is true, and if minimum is greater than or equal to my top of my stack, top st.top. If that's the case, then I will simply pop until my condition is true. Return st.pop. Right. Now if I'm out of this, my stack size can be 0, right? And then I have to check the condition if j value is greater than top stack element. So first, if stack size is not 0 and j value, so I will requiring j value. So here we got index, right? So int j value equal to nums j, right? So here let's write it. J value is greater than st.top, is greater than st.top represents k, right? If that's the case, that means we got our answer. So for storing our answer, I'm going to create a Boolean variable found that is initially false. If I found my answer, I'm gonna make it true. And if 132 pattern my code follows, if my input follows, I'm gonna simply break. No need to check further, right? And then don't forget to push your element st.push nums j. Perfect. And at the end, we return found. Return found. Now let's try to run our code and see if this works or not. Min 0, 7th line. Okay, so it's min array. Okay, now let's try to run it again. If there is more errors, we'll fix it, but no errors. Perfect. Now let's try to submit it. It's passing all the test cases. Perfect. So yeah, that's it for this question. We discussed multiple approaches here. Very interesting question. If you like this video, do not forget to like, comment, and share. Thanks for watching.